The integers r, s, and t all have the same remainder when divided by 5. What is the value of t? So quick detour to start. Anytime I see a question that is asking me for the remainder when dividing by 5 or when dividing by 10, it always stands out because these have sort of special patterns to them that I wouldn't say is required you memorize, but certainly if you're aware of them, they could help in certain situations. So let's talk about those here. So I'm just going to write out 10 consecutive numbers. And then, so if we're talking about the remainder when we divide by 10 here. So if we started with 20, 20 divided by 10 is 2 remainder 0. So if we start at remainder 0, we're going to go up to remainder 9. And then our pattern is going to repeat. And so once we get to 30, it will reset back to 0. And so what you might notice here is that our remainder is always equal to our units digit. And this will be true for any number that we divide by 10. So if you ever see a question where they're asking what is the remainder when x is divided by 10, that is the same as asking you what is the units digit of x. So what will happen when we divide by 5? So to start, we will have the same pattern, but once we get to 4, then the pattern resets here. So we go back to 0. And so in this case, it's a similar pattern to start, but then units digits of 5 corresponds to 0, and 1 corresponds to 6, 2 corresponds to 7, 3 corresponds to 8, and 4 corresponds to 9. So similar, but not the exact same pattern. So let's see if we can make use of this with regards to our question here. So statement 1 says r plus s is equal to t. So if we want to come up with some examples of what t could be, and we need to make sure that our values for r and s have the same remainder, the easiest examples to come up with should be ones with where r, s, and t are multiples of 5. They all have remainder of 0. And I know that if I add two multiples of 5 together, I should get another multiple of 5. So let's say r is 5, s is 10, then t is 15. This checks out because they all have a remainder of 0. But then let's say r is 10 and s is 15. Then t is 25. So this also checks out because we got all remainders of 0. But we got 2 possible values for t, so this is insufficient. Statement 2 says t is between 20 and 24 inclusive. So t can be 20, 21, 22, 23, or 24. Okay, so these are all going to have different remainders. And I can certainly find values for r and s that just are numbers that have the same remainder. It doesn't even say that without our first statement, rs could be literally the same value as t. So this is going to be insufficient. So now looking at them together is where we got to think for a bit. So let's say, because remember, all we really care about here is our units digit. So if we start off with some number with a units digit of 0, and we want to get to another number with a units digit of 0 or 5, that means. And so I can add something with a units digit of 0 to something with a units digit of 5, and that should get me back to remainder 0. So 15 plus 5 gets me to 20, and that's within our range here, right? And so in this case, all our values have a remainder of 0, so that's one possibility. So now I just need to see, and I'm looking at them together now, can I come up with a similar thing with a remainder other than 0? So let's say we start talking about remainder of 1. So that means I can either add numbers with a units digit of 1 or numbers with a units digit of 6 to each other, but 1 plus 1 is equal to 2, so that won't work, and 1 plus 6 is equal to 7, so that won't work, and 6 plus 6 is equal to 2, so that won't work. So none of these numbers are going to, even if I could get one within the range, they're never going to have the same remainder. And so now if we're talking about remainder 2, so I got to be adding either numbers ending in 2 or 7 to each other, and so 2 plus 2 is 4, so that won't work, and 2 plus 7 is 9, so that won't work, and 7 plus 7 is also 4, so that won't work. So there are no two numbers here that I can add together to give me a third number with the same remainder. If we're talking about remainder 3, I can only be adding a number ending in 3 or a number ending in 8. 3 plus 3 is equal to 6, though. 3 plus 8 is equal to 1. 8 plus 8 is equal to, has a units digit of 6 as well. So none of those will work. And then the only other option I'm left with is remainder 4. So 4 plus 4 is 8. So I'm looking for only 4s or 9s here now. 4 plus 4 is 8, though. 4 plus 9 is 3, so that doesn't work. 9 plus 9 is 1, so that doesn't work. And so I cannot have two numbers with a remainder 4 add to get to some other number with a remainder 4, certainly not within this range. And so our only option that we can come up with are ones where our remainders are all 0, and therefore we can say together they are sufficient to say the remainder will be 0 when we divide by 5. C, hard, tough question.